Welcome to today's STEM activity. Today, we're going to explore the basics of electrical engineering and design by creating our own paper lanterns. Paper lanterns have a rich history and are used worldwide for celebrations, particularly Lunar New Year. Paper lanterns come in three main types: hanging lanterns, which can be carried, hung, or mounted; sky lanterns, which use a small flame to float like a hot air balloon; and water lanterns, which float on the water's surface. They create a beautiful spectacle while illuminating areas. However, in today's activity, we'll be creating a safer and more sustainable version using LEDs. Here's what our finished product is going to look like. Let's start by designing our lanterns. Grab a piece of paper. I use construction paper for this activity. You're going to take your piece of paper and place it horizontally. About an inch from the edge, cut off a strip of paper. This will be used as the handle. Since I'm using smaller construction paper, I'm making a little bit of a smaller cut here today. If you have some younger learners that are doing this activity with you, they might need a little bit of help getting the line straight, but it's okay if it's not exactly straight. Mine's not straight. That's okay, it'll do its job. Fold the remaining paper in half, long ways or horizontally, just like you're folding a paper airplane. About an inch from the edge, you're going to create a mark, which will serve as our line. Now, using a long edge or a ruler, if you have one, you're going to mark that line all the way from the bottom of your paper to the top. This will be our reference point for where we can cut. If you use a pencil, you can erase the lines later, but I'm going to keep mine as part of my design. Now that we have a horizontal piece of paper folded in half with one line going horizontally towards the top, we're ready to start making our cuts. You're going to take a pair of scissors and cut even slits from the beginning all the way through the end. These slits don't have to be exactly even. As you can see, mine aren't, and younger learners might have trouble gauging the distance, so that's okay. They just have to go from the beginning of your paper towards the end of your paper. So you can see here, what I'm doing is I'm cutting up to the line that we made previously. One trick to help learners remember which side they're cutting on as well is to tell them to think of their paper as a book. And we are cutting the spine of the book. So your book always opens like this, right? You're going to be cutting on the side that does not open up. Now that we have all the slits, we're ready to start creating our lantern shape. We're going to take our piece of paper. As you can see here, I have even slits from the right to the left. I'm going to take my paper and I'm going to fold it into a tube shape. Smaller hands may have a little bit of difficulty with this as well, so you might want to give them a hand getting their lantern into a tube shape. I've generally found that once they have one part of the tube secured with tape or glue dots if you have them, the rest of it is a little bit easier as they're able to get the second bottom part on their own. Make sure it's nice and secure and that your tape or your glue dots are covering both sides, the inside and the outside of your lantern. This is our lantern base. So now that we have our lantern base, we're ready to attach the handle that we created previously. Now I'm using tape for this activity, but if you're using glue dots, you're going to want to have your learner put the glue dots on the same side of their paper and then attach them like this, so that the inside of the tube is covered where their glue is. If you are using tape, I like to add an extra piece of tape on the outside of the lantern for extra stability. It's important to note that for engineering and design, we want the least amount of points of failure. So the handle offers extra points here. So adding these additional pieces of tape or glue dots will allow our lantern to be even more secure, especially as children pick up and they may tug on their lanterns. And there we have our base. As you can see, my lantern's a little bit floppy, and that's okay. I kind of like it. It's got that old-timey feel to it. Beautiful. So now that we've created our lantern base, our lantern is ready for some light. We're going to be using two of my favorite objects today, an LED and a coin cell battery. The coin cell battery got its name because it looks like a coin. The LED got its name because it is a light-emitting diode. I don't know where that came from. Let's get into the basics of electrical engineering by adding these LEDs now. LEDs are devices that emit light when an electrical current passes through them. The LED has two legs, the long leg, or the anode, which is associated with a positive charge, and the short leg, or the cathode, which is associated with the negative charge. To light up our LED, we need to create a simple circuit. In a circuit, electrons flow from the power source, in this case, our battery, to the LED, powering it, then back to the power source. So though we can't visually observe this in our LED here, right now there are electrons flowing here from the power source of our battery, up through the legs of the LED, and back into the battery. That's how electrons work. If this flow is disrupted, we call that an open circuit. For example, if our LED is not attached correctly, say if one leg is slightly askew, you'll notice that the circuit is not complete, and as such, electrons are not going into the LED, so it is not able to power. When we close the circuit, the LED lights up as electrons are able to flow normally. This is complete and also referred to as a closed circuit. Now, let's bring this knowledge into action. As we connect the long leg of the LED to the positive side of the battery and the short leg of the LED to the negative side, you'll notice here that it's very easy to delineate on a coin cell battery which is the negative and which is the positive. Generally speaking, a coin cell battery will have a plus on it as well as the name of the battery or the brand, and it'll have something like CR2032 or perhaps something very similar to that series of numbers. Whereas the negative or the ground side just has a blank slate. So always your long leg goes on the side with the writing. Your short leg goes on the blank side. For younger learners, that's a really easy way to remember. Long leg, writing. Short leg, blank. Easy peasy. I'm going to use a piece of tape to secure our LED to this coin cell. Now, I would generally advise when you're using tape to secure any kind of batteries and coin cells and any kind of small components like this, use a very long piece of tape, because what you can do is you can kind of wrap it around itself and create this tension-based secured system in which movement will not dismount or wiggle out your LED. So the circuit will remain closed. The electrons are able to flow and your LED will light up just as you intended. You can add an extra piece of tape to secure it. I always recommend that, considering lanterns are meant to be picked up and walked around, so they're gonna move around a lot. You can't lose with adding more points of security. Now, you can choose where you want to put your LED on this lantern. Personally, I think it'll look pretty spiffy right here at the top. Additionally, you may choose to add more than one coin cell battery and an LED to your lantern, or you may choose to add multiple LEDs to one coin cell. But as a reminder, coin cell batteries are a power source that are not unlimited, so you might begin to see diminishing returns on your light and power. So here's a pack of fresh coin cell batteries. We know that the power is going to be completely full. One way of also testing this is by using a multimeter if you have one accessible. The first LED I'm going to place on the coin cell is blue. I'm going to place another blue, and then a yellow. And you'll notice, when I place the yellow one, the blue ones immediately turn off. This is because yellow requires a lot of power, and there's not enough power in the battery to power all 3 of the LEDs at once. So if I take the orange or yellow one off, the blue one will light back up. Have your learners experiment with this because it's a really interesting display of how a limited amount of power can do a limited amount of things, as well as it's just kind of a fun light show. To add a final touch to our LEDs, we're going to use some tissue paper to make some streamers. Again, younger hands might have a trickier time getting straight lines, so you may also want to model that, you know what, mine are not that straight either. See, I have scissor lines. They're not the same length. They're kind of all over the place, and that's okay. Science and electrical engineering is about experimentation, and when we don't get something right the first time, we are encouraged to keep going. I'm going to use tape to secure these. If you have glue dots, that also works. Voila! There we have it. A glowing LED paper lantern. Feel free to experiment by adding multiple LEDs to one battery, or by adding multiple batteries and LEDs if you have the supplies to different parts in your lantern, and then experiment with what the LEDs look like when the lights are off, if you have that possibility in your classroom. Remember, experimentation is the key to learning in STEM, so have fun and enjoy your lanterns. When you're working with things this small, even with adult experienced hands, they can be really tricky. For example, you might have your LED perfectly in place and taped on, and then it will slightly wiggle out and it will open your circuit up. Don't get frustrated. Electrical engineering is a very difficult topic. We're working with very small components, and the best thing you can do for both yourself and your learners is to just experiment with it. Model yourself being frustrated sometimes with your LEDs and say, oh, you know what, sometimes these silly, tricky things just don't work. That's fine, because at the end of the day, we're really excited because we're making something light up, which is amazing. Science is kind of magic, and we now have the power to create it ourselves. So make sure that you're reminding your learners, if it's not working the first time, they are going to develop the tools to actually diagnose and figure out why, and then go back and fix their problems. It's a really empowering tool to have as a learner and as a human being.